everybody. Welcome to this session. I'm Rebecca Minghella, the CEO and founder of Clarity AI. We are going to be talking today about the next power play in physical to digital infrastructure. Global electricity demand is accelerating rapidly, expected to grow more than 25% by 2030. There are different estimations that go up to 70% in 2050. That is driven by increasing demand of electric vehicles, air conditioning and heating, and of course, AI and data centers. In this session, we are going to talk about the challenges and the opportunities and a few solutions to this challenge as well. For this discussion, we have the leaders and experts in this topic. It's my pleasure to introduce, and sorry for my Spanish accent when I pronounce your names, please. So we have Joe Bamford, is the chair of the executive committee of HYCAP Group, a pioneer in clean mobility and green hydrogen investment. We have Torbjorn, chairman of Actis, one of the world leading investors in sustainable infrastructure across growth markets. We have Laurent, Germain, is the CEO of Egis Group and a leading voice in international infrastructure collaboration, and Sylvie Jehano, who is the CEO of Dalkia and part of the EDF group and a leading force in energy efficiency and decarbonization. So let's dive in, and let's start first, of course, with the challenges and opportunities that we are seeing right now and that we are already working to address. So, Joe, do you wanna start?
Well, of course, the challenges at the moment are people are slightly going away from energy transition. But it is one of the most wonderful opportunities in the world. We find ourselves, of course, here in Saudi Arabia, where not only is it doing a huge amount of energy, but it has the lowest cost of energy in terms of solar coming forward in terms of energy transition. Of course, the challenges of that is finding markets and how do all of these pieces stack up? How do you deliver both solar and then turn that into a fuel, in my case, in the world of hydrogen, and then find a customer, and in my case, we put it into a bus, and deliver a solution that works ideally without subsidy, so you can give people a real-world application that they don't have to change their behavior. All of those things are quite difficult to do, but we are doing that in the UK, and it would be delightful to do that here.
Thank you, Joe. Torbjorn, you have had the opportunity to work on the mismatch of supply and demand, mainly in growth markets, right? Could you please tell us a little bit more about that?
Absolutely. No, so I mean, the opportunity is clearly a massive one if you're now thinking about the non-US and non-European markets. And in one way, you can say growth market, but you can also say most of the world, because that's where 85% of the world population lives. This is where we have 2/3 of all the investment opportunities in infrastructure, yet you only have 1/3 of the capital chasing it. So that creates a very attractive risk return for us to invest and build and create new infrastructure in these markets. And Joe, you mentioned, for instance, transition. So in one way, you can say transition, yes, I mean, it's still there, but in our markets, it's more energy addition because you need new power and new electricity and new infrastructure, and that's what we're providing there in most of the world.
Thank you, Torbjorn. And Laurent and I were briefly chatting before about the challenge of the lack of resources and how that's really impacting this mismatch between supply and demand. Could you please elaborate a bit more on that topic?
So I think we have a tremendous challenge in front of us because the level of resources available in order to implement the solutions and the projects is not enough. Just one figure that will tell you the gap that we are having. The Financial Times published in the UK the vacant jobs for civil engineers. The vacant jobs have increased by 84% in the last 3 years. So we're not producing enough engineers each and everywhere in the world, not only in Europe, but also in the States. You know, the States are investing billions and billions in infrastructure, but the number of graduates, engineers, are not enough in order to match, I would say, the demand. In France, we are graduating 45,000 engineers a year. We are missing 10,000 engineers a year to meet the needs of the market. You know, we are lacking competences in data scientists. We are lacking engineers in neutronics. We are lacking engineers in many different areas, and if the educational systems don't, I would say, increase the number of graduates and the firms do not train at the right pace, we will miss the targets that we have in terms of, I would say, increase in the infrastructure and the energy by 2030 or 2050.
But do you think the educational institutions are going to be able to move fast enough to train and educate?
Well, if I take the example of the nuclear sector in France, so we took the political decision to launch and to build 6 new nuclear plants. We had given up doing the nuclear plants for several decades in France. But in a few years, all the stakeholders have been able to gather around the table and define a plan so that the number of available workers and also engineers in that part of the business increases gradually, so that at the end of the decade, we come back to the level we had when we were building a few nuclear plants a year. So it's possible, but it's just a political will and investment.
The political will, that's something that we really need these days. So we have been talking about renewable energies and the emerging markets, the lack of resources, and there is something that is very important as well, which is the energy efficiency, of course, and decarbonization when we are expecting such an increase in the demand. Sylvie, you are an expert on that topic. Could you tell us a bit more about how are we going to address that challenge of getting to the energy efficiency and decarbonization as well?
Yes, so first of all, hello to everyone. Of course, for Dalkia, energy transition is one of the biggest challenge we have to tackle. And because of the growth we've just spoken about that, the International Energy Agency say that the demand of energy will increase by around 50%, 15% from 2023 to 2050. So it will be huge. And we will have also to tackle with the climate change and energy transition. And I think it's not a question of technology. How can we decarbonize? How can we do 2 things? At Dalkia, we say, because it is our jobs, we say to decarbonize, we have 2 things to do. First, to consume less, and then to consume better. To consume less is to save energy, to develop energy efficiency, and to consume better is to consume more and more low-carbon energy. It is a transition. And to succeed in that, I see, in my opinion, we have 3 choke points to challenge. The first one is the rhythm. What is the good speed to succeed in energy transition? Because we need vision, we need frameworks to do that, and not easy to determine the rhythm of that. The second point is also what exactly Laurent said. We have a skills bottleneck. I think so. Engineers, of course, but also technicians, because specific skills, and we will need technicians, engineers, and women also, and also digital skills to succeed in energy transition. And the third point I would like to raise is, we need coordination. We need that cities, politics, companies like me, energy services company, utilities, coordinate a lot, because I think that we will succeed if we think global and act local.
And I'm going to ask you a follow-up question, Sylvie. If you have to rate the main geographies on those topics like Europe, APAC, Americas, on the agility or the rhythm, the skills and the coordination, where do you think we are lagging behind? Which geographies? Do you think there are geographies that are lagging behind and others that are maybe leading the way?
In each country, there is an equation in each country. In France, of course, it was much more a heating country of heating. Here, it is much more a country of cooling. But now in France, it's both. In the UK, it's much more heating. And we have to be very customized with our customers. And what will be key is our ability to integrate ecosystems with multi-energy. And we have so many solutions. I will give you an example. In Lyon, because we are a specialist of district networks, heating and cooling, we have a district networks for cooling and heating, both in France. And for heating, we recover energy from a waste incinerator, and we recover energy from an industrial site. And to do cooling, we recover energy from the Rhône, the river in the town. And also we have storages, different kind of storages. Storages for ice, storaging for also hot water. And to optimize that, we need digital solutions. And everywhere in the world, we have to think of the good equations, to think of the good customized solution to enhance energy transition.
Yeah, that's actually a good segue because we want to talk about solutions. We have here leading experts on the topic that are also walking the talk and implementing solutions to close that gap between supply and demand in different ways. So Sylvie already provided one of those good examples. Joe, can you also give us one example on your experience?
Sorry?
An energy transition and how we close the gap. An example about renewable energy, in your case, hydrogen.
So look, we manufacture end-use customers. We manufacture construction equipment. We're the third largest manufacturer of construction equipment in the world. We manufacture buses. And why do we do energy? Well, we look at energy and how these businesses are going to change. So we don't just manufacture those. We manufacture filling stations, compressors, the whole value chain of that. And we also manufacture energy. We turn water into fuel, into a hydrogen. That hydrogen then goes and fills the bus up. Takes 5 minutes to fill the bus up. The bus then goes and does a day's work and comes back, and it's zero emission. We are constantly trying to drive a cost base of that works without subsidy in a real-world application. But you need every element of that to turn up at the same time. How we're using energy today is, of course, changing. And we're now starting to find in your world, of course, data centers are starting to consume more and more energy. And becoming one of the biggest problems is energy grids. How do you move energy around and connect to that grid? Look, the way we've used energy for the last 100 years has kind of been rather boring. We use electricity for lighting, gas for heating, and combustion for motion. And we need to replicate all of those and use all of those to get an energy transition, make them work for the customer, and then drive a total cost of ownership to a customer that works without subsidy. And that is what we do, and that's why I sit in both production, distribution, and end use case, and even financing it, so that the customer, we take the problem away from the customer.
Very interesting. And also another example of energy transition, Torbjorn, is on solar energy, right? That project, a large project that you did or you were doing at Actis at the moment?
Absolutely. I mean, if I just start where you ended there with the subsidies, I think that it's important to create infrastructure with zero subsidies. You need systems that really are self-sufficient in the way that then they provide electricity. And if you take some examples of the markets we are in, the sun in general shines more, the wind blows more, so you get very, very efficient renewable energy. And take some examples here. We are building one of the world's largest, maybe the largest, solar and battery project right now in the Philippines. Massive, and it will be 2.4 million homes that will be able to get clean energy from us there. You can see from space as well. But I mean, it's a change in how renewables now is totally commercial, and combining it with battery, you can also provide electricity when the sun is not shining. So that whole change is happening. And you can see that same in India. We have a number of projects that we're now doing where you have a combination of wind, solar, and battery. And through that, you can actually deliver capacity and firm energy. And you can see the similar thing then across, say, Brazil, which is one of the windiest places, or Central America. So if you're looking at most of the world, again, where 2/3 of the world population lives, it's a perfect opportunity to install and build new renewable energy and create that low-cost green energy.
We are talking about hydrogen, about solar. What about nuclear, Laurent? We were talking briefly before about that. So
I think the first integrated solution is to have a political consensus on not opposing the sources of energy anymore. All the sources of energy will be needed if we want to increase the production of electricity by 70% by 2050. So that's the first integrated solution. The second one for us is the way we design and then we exploit the infrastructure. It has to be done in a respectful way for the environment. This is the methodology that my company Egis is implementing. It is called eco-design and eco-exploitation of the infrastructure. It's making sure that the engineers work on the least damaging solution in design and then in the operations and maintenance of the infrastructure. And more than 70% of our projects now are eco-designed and eco-maintained. And in order to do that, we use technology. We use digital twins where we can simulate and get the impact of this or that choice, technically, on the environment, and then retrofit and in the end choose the less damaging solution for the environment. And of course, we are using AI. AI brings a lot in the conception phase. That helps us to, if I take the building, for example, the use of AI can help us to diminish by 14% the consumption of electricity, of energy in the building. So AI, of course, will be a huge tool, but will never replace the engineers. Why? Because also we need to be designing infrastructure which will be more resilient, because climate is having an impact on infrastructure much stronger than a few decades ago. So we need to integrate in the design not the climate data of today, but the climate data of 20 or 30 years from now. And so only the engineers, not AI, can take the data from the experts on the climate that will happen, the phenomena, in 20, 30 years from now, and integrate them in the current model in order to design and to make the technical choices in design for this infrastructure to be more resilient in 20 years.
And Sylvie, to that point, actually, Laurent is talking about energy efficiency as well, and the use of technology and AI to bring that energy efficiency. As you said before, we need rhythm, we need the skills and the coordination. If you were to highlight one of the three that you think is more needed right now, and how we could have
I would like to, it is a transversal topic, and I would like just to add something about digitalization, because it is absolutely transversal, and it will be key it will be a key success factor to succeed in energy efficiency. And also for energy management in general, because we are speaking together about multi-energy systems, electrification, and also local energy and energy recovery, and also energy management. And we will need digital platform to do that and to go further. For example, we operate the cooling networks in Misk City. I think you are in Riyadh, in Misk City. And we did a digital twin to optimize the solution. We are also a big partner of the energy efficiency program in Riyadh with Tarshid, and we put digital the digital systems everywhere. We have what we call at Dalkia a desk, Dalkia Energy Saving Center, to manage energy, to see the data, and to create value with the data. And AI, it is a revolution. AI will be everywhere. We have specific models with AI, and I think it is the beginning of the story. And Gen AI will be also a big revolution to help us to go further in energy transition, in energy management. And I think for me, as a CEO of Dalkia, I have two challenges to tackle with AI and Gen AI. First one for my customers, for energy transition, to optimize everything, first one. And the second one is also for the company itself, because we will have to think about the impact of AI for our employees to enhance profitability, but also to enhance well-being at work, for example. So it is a revolution, but I'm sure we have to be optimistic, because it is a real lever to succeed in.
I would like, you said we have to be optimistic. I would like to hear from each of you if you are optimistic or pessimistic about closing that gap by 2030, before we talk about a call to action at the end. But are you optimistic or pessimistic about getting to close that gap of demand and supply in energy by 2030 or 2050?
I think by 2050 you can do it, but you have to follow through a lot of engineering changes, which is why you have to look at it. We've discussed nuclear. Nuclear has got its own challenges. We're changing through. We've got light water reactors at the moment, going to SMRs and then AMRs, but they've got to get the cost down. You've got to figure out how you're going to move energy around. I mean, we at the moment use it through the grid, and lots of people try and use the grid, but the grid is going to become your problem because there's only so much infrastructure you can put in. Then you've got to start looking at the hard-to-abate areas, and each one of them you've got to find a solution that works, that customers want to buy, that customers want to find that works in a real-world application. And this is why we're quite concentrated on what we do, which is energy, distribution of energy. We're also into the manufactured goods. One of the biggest problems with engineers, they get terribly excited by their product, but they forget that that product's got to work 99% of the time, all the time. Most of the people who are designing these products are terribly excited by the idea of it, but forget that it's got to work, and you've got to get the people filling it and charging it and operating it all the time. So I'm very optimistic that we can do it. I'm hopeful that we can turn some of this energy around and move it around. I mean, take this place. You've got a huge amount of solar, and sometimes with solar and batteries you can't move it, so you have to turn that into another form of energy and move that around the world. There's 3 or 4 options to that. Hydrogen, you can do it with green ammonia. Each one of them have got their own engineering challenges, but I mean, as an engineer, it's kind of exciting. We have a new set of train sets to play with. For the last 100 years, it's been a bit of an iterative process. An engine's got a little bit better every year. Well, now we have all these new train sets to play with, and we have to find a solution that customers want. But we will find that solution. We are finding that solution. It's maybe not happening as quick as some people would like it to, but it's really getting there.
Yeah, so optimistic then, Joe. And Torbjorn, are you optimistic?
I am. I'm also an optimistic side here. I mean, I'm thinking, if you look at that growth that you started our session with here, yes, it's massive. And if you're looking at just economic growth and then electricity, that growth with a multiple of economic growth. So without any AI or anything else, if you go forward 20, 30 years, we need to build another planet, a power plant. You said 7%, but it's about the planet, the power plants. And electricity is humankind's largest investment ever. Now going to do another planet. And on top of that, you have electrification to vehicles, you have AI and so on. So clearly the need for new electricity is absolutely massive. But I think that the technology is there. Hopefully engineers are there as well. Being an engineer myself as well, you were too, I heard Joe. So I think that we actually can deliver it, and if we're just making sure that we get the capital to the right places, the private sector can play a really important role here and deliver this. So I'm on the optimistic side.
I'm optimistic too. So Laurent, are you optimistic? So we have 3 optimists here today,
Yes,
so.
I'm very optimistic. Egis is in a privileged situation because we are working in each and every sector. Roads, rail, environment, water, energy. And when I see, the dynamism of my markets, the energy market is going to be the most dynamic, is already the most dynamic between all the different markets in engineering all around the world. Why? Because a lot of investments are done not only in energy production, but also in energy transmission and distribution. Everybody has realized that the grids, the electric grids all over the world, are not dimensioned to welcome, transport and distribute the amount of electricity which will be produced. And so, for instance, the operator in France, RTE, is going to spend 100 billion euros of investment in the next 10 years in the upgrade of the electrical grid. That means that production of electricity will anyway increase significantly. And so I'm very optimistic.
And Egis is present in more than 100 countries, right?
My company, is present in more than 80 countries, so I've got a good elements of benchmark.
Good footprint to be optimistic about, yeah. And Sylvie, so you were saying you are optimistic as well, but also optimistic about the timeline, because Joe said we will get there by 2050. You think it's going to be earlier than that, or you think we can catch up with...
Of course, it is a question because, we will need very stable framework to accompany everything, because it's not so easy to succeed in an energy transition. It is a transition. It will be progressive. The rhythm is not so easy to determine, and to succeed in that, we will need stable framework, maybe regulations, maybe subsidies. It depends on the country. It depends on the economics everywhere, because for example, presently the prices of energy is not so high, so not so easy to decide to save energy. The price of energy is not very high. So what is my driver? If I want to, for example, to change my boiler, I am an industrial, and I would like to change my gas boiler, but the price of the gas is quite low. So what is my driver? What can help me to decide? For example, in some countries we have subsidies, we have some programs, and I think we will need some stable programs to help people to decide, and to determine also different equilibrium, because we spoke about, for example, demand and supply. The balancing is not so easy. The question of grids also to tackle with. But I am optimistic because the solutions exist. So, and we gave many examples. So I am.
Yeah, and you touched upon something very important, which is the regulation, the subsidies, the prioritization, right? You said how we can decide what are the main drivers. So maybe in the last 4 minutes that we have for this session, each of you can tell the audience, what is your call to action? What is that one thing? Because we need to prioritize. We have so many things, there are so many topics, right? So what is the one thing that you believe we need to work on right now, the main thing that we need to focus on? Let's start with you, Joe.
Well, of course, being selfish in what I do, look, there's a great opportunity in this part of the world, both by giving volume order for the end-use customer. Let's say you gave me an order for 1,000 buses every year for the next 10 years. I'll give you 15,000 jobs at every part of the supply chain, so bus, fuel cell, tank, and then you've got hydrogen offtake. And with the solar being so cheap, we can make hydrogen at a very similar price to diesel. Now, if you get that right with that volume, exactly what China did on batteries, you can then export that around the world. And particularly here, which is an energy exporting country, wouldn't it be cool to also export the manufactured goods over the next 30 years and be able to move away not just from energy, but to the whole supply chain? That, I think, is a wonderful opportunity.
So the call to action is more like the integration across the entire supply chain, right?
Yeah, I integrate the whole supply chain and try and give a customer a real-world application that they would like.
Okay, Torbjorn?
I would say, being an investor, capital is not a shortage. So in order to deliver, we need transparent regulatory frameworks established in the various countries. And if you do that, investors like us, and we are builders and operators who construct and build infrastructure, we will come and we will be there and we will build green, reliable, affordable, sustainable infrastructure and power specifically. So get those transparent frameworks in place and capital will come.
Yeah, like Sylvie was highlighting before as well. Yeah, Laurent?
Well, if you look at the two zones, which are the most dynamics, what do they have in common? So it's North America and here, the Middle East. First, a long-term vision. A political long-term vision. That is necessary with, I would say, the financing that goes with it, be it public or private. And of course, the US and the Middle East, I mean, in the case of the US and Canada, they have the greatest private equity firms in the world with the highest level of capital. And here, you've got the most, or the richest, sovereign funds in the world. So they have that in common. And the last thing is the involvement of the private sector. There are sectors, we spoke of the nuclear, where we thought only, public money could be used in order to finance some projects. Recently, Sizewell C in Great Britain was financed partly by the private sector with, guys like CDPQ investing in the equity. So what was seen as impossible in terms of getting the public sector involved has become possible because the contract was written in a way that the private sector was ready to take the risk, even in a sector like nuclear, where it was seen as impossible.
Thank you, Laurent. And Sylvie, in the last few seconds, your call to action.
Yes, very quickly, because the title of our roundtable is, power play in physical to digital. So just to say again that data will be key, and it will be key to optimize, to do energy management, also to build trust, I'm sure, and don't forget to consume less and to consume better.
Thank you very much. Thank you to all my wonderful speakers today. It's a pleasure sharing this panel with you. And just to wrap up, we have very important challenges and opportunities ahead. But as you know, we have very strong leaders already working on it. And hopefully with the mix of the public support, private markets as well, we can address that challenge of that 25% increase in energy by 2030. So thank you very much.
Thank you.
Thank you very much.
Thank you.
Thank you all.